India is the first country in the world to land a spacecraft near the moon's south pole.
Knowing Neil deGrasse Tyson, a renowned astrophysicist, he would always commend and highlight feats in space exploration. But what India has recently discovered could have terrified him, as such revelations never came out for the past decades, even when Armstong and company announced to the world that the moon was just a dead rock and no water. What astronomical changes could have happened up there? Chandrayaan-3, a leap in India's space exploration journey. Thanks to India's persistence, humans have landed on the moon again. India's space exploration journey has been one of remarkable growth, with the country gradually emerging as a formidable force in the global space community. Among the key milestones in this journey is the successful launch and execution of the Chandrayaan-3 mission, a critical leap forward for India's ambitions in space exploration. This mission not only showcases the prowess of the Indian Space Research Organisation, ISRO, but also highlights India's increasing role in the global space race, as well as its commitment to advancing scientific knowledge and technological innovation. Launched on July 14, 2023, Chandrayaan-3 marked India's third lunar mission. Unlike its predecessors, Chandrayaan-1 and Chandrayaan-2, which focused on mapping the lunar surface and searching for water molecules, something past expeditions did not discover, Chandrayaan-3 had a singular focus: achieving a successful soft landing on the moon. This goal was especially important given the challenges faced during Chandrayaan-2, where the Vikram lander lost communication with ISRO during its descent. The Chandrayaan-3 mission, therefore, represented both a technical challenge and a chance for redemption, not just for ISRO, but for the entire nation. The mission's primary components, an orbiter, a lander, named Vikram, and a rover, named Pragyan, were meticulously designed to ensure that the landing would be precise and stable. The lander was equipped with advanced sensors and technology to measure lunar conditions, while the rover was tasked with analyzing the moon's surface, particularly in the uncharted region near the lunar south pole. This area, believed to hold water ice, is of particular interest to scientists as it could serve as a potential resource for future lunar missions. Chandrayaan-3's success was a moment of immense pride for India, but it also marked a significant leap in the nation's space exploration capabilities. The successful soft landing on the moon placed India in an elite group of countries capable of performing such a feat, alongside the United States, Russia, and China. This achievement not only demonstrated India's technological and engineering expertise, but also cemented ISRO's reputation as a reliable and efficient space agency, capable of executing complex missions with relatively low costs. Moreover, the success of Chandrayaan-3 has broader implications for India's space ambitions. The mission is a stepping stone for future lunar exploration and sets the stage for more ambitious projects, including the possibility of a manned lunar mission. Additionally, India's growing space capabilities open doors for increased international collaboration. Countries around the world are keen to partner with India, leveraging ISRO's cost-effective and reliable technology. This collaborative spirit strengthens India's position in the global space community and creates opportunities for shared knowledge and progress. Let's take a more specific look at the new and surprising discoveries they unfolded about the moon. A detailed look at Chandrayaan-3. One of the most significant aspects of Chandrayaan-3's mission was its focus on the lunar South Pole, a region of particular scientific interest. The South Pole of the moon is believed to harbor water ice, which could potentially serve as a resource for future lunar missions, offering fuel for rockets and drinking water for astronauts. By targeting this region, India has not only contributed to lunar science, but also positioned itself at the forefront of a new era of space exploration that focuses on sustainable living on the moon. Chandrayaan-3's Pragyan rover and Vikram lander were equipped with sophisticated instruments to analyze the composition of the moon's surface. One of the most important findings from the mission was the identification of specific elements and compounds on the lunar surface, including key minerals and metals that are critical for understanding the moon's geological history. The rover's analysis of the lunar soil samples provided valuable data on the mineralogical composition of the moon, particularly in the region around the South Pole. These findings contribute to the broader understanding of the Moon's evolution, its volcanic activity, and the processes that have shaped its surface over billions of years. In addition to the identification of water ice, Chandrayaan-3 also discovered new insights into the Moon's regolith, the layer of loose, fragmented material covering the solid bedrock. The rover's instruments measured the abundance of various elements, including oxygen, silicon, iron, magnesium, and calcium, all of which are important for understanding the Moon's mineralogy. These findings could provide valuable clues about the formation of the Moon, as well as the processes that have occurred since its formation, such as the impact cratering that has shaped its surface. The Chandrayaan-3 mission also offered a deeper understanding of the Moon's exosphere, a thin, tenuous atmosphere composed of particles that are constantly replenished by solar wind and lunar dust. The lander and orbiter collected data on the exosphere, shedding light on its composition and behavior. This data is crucial for understanding the Moon's interaction with solar radiation and the potential for future human habitation on the lunar surface. Chandrayaan-3's discoveries are not just significant for lunar science, but also for the future of space exploration. The presence of water ice on the Moon, for example, opens up the possibility of long-term human presence on the lunar surface. By extracting water from the Moon, astronauts could sustain themselves and produce oxygen and fuel, making lunar missions more feasible and cost-effective. This discovery also positions the Moon as a potential launchpad for future missions to Mars and beyond, as it could serve as a refueling station or a base for astronauts to prepare for longer journeys into deep space. Furthermore, the mission's success enhances India's reputation as a leading player in space exploration. Chandrayaan-3 not only advanced India's capabilities in space technology, but also cemented its place among the elite group of countries that have successfully landed on the Moon. The scientific data gathered from the mission contributes to the global understanding of lunar science and strengthens India's role in international space collaboration. Through this mission, India has not only advanced scientific knowledge about the Moon, but has also cemented its place among the elite spacefaring nations. As ISRO continues to develop its space capabilities, Chandrayaan-3 serves as a crucial stepping stone, setting the stage for even more ambitious lunar exploration endeavors in the future. The mission's success reflects India's dedication to scientific discovery, technological innovation, and global collaboration in the pursuit of a deeper understanding of our solar system. The Chandrayaan-3 mission faced numerous technical, logistical, and environmental obstacles, many of which had to be overcome through meticulous planning, innovative solutions, and a spirit of perseverance. Challenges faced and overcome in the Chandrayaan-3 mission. These challenges highlight the complexity of space exploration and the resilience required to push the boundaries of scientific discovery. One of the biggest challenges faced by ISRO in the Chandrayaan-3 mission was overcoming the setbacks of its predecessor, Chandrayaan-2. The Chandrayaan-2 mission, launched in 2019, aimed to land on the lunar surface, but encountered difficulties when the Vikram lander lost communication with mission control during its descent. This failure created a significant setback for ISRO, both in terms of technical challenges and the loss of valuable data. However, rather than being discouraged, ISRO used this failure as a learning opportunity. Engineers and scientists carefully analyzed the data from the Chandrayaan-2 mission to identify the cause of the failure and made necessary adjustments to the design and operation of Chandrayaan-3. The lessons learned from the Chandrayaan-2 mission led to critical improvements in the Chandrayaan-3 mission. For instance, ISRO made modifications to the lander's software, ensuring better navigation and control systems. The failure of Chandrayaan-2 also highlighted the need for enhanced communication systems, which were incorporated into Chandrayaan-3 to ensure that the lander could communicate effectively during its descent. By addressing these issues head-on, ISRO was able to increase the likelihood of success for Chandrayaan-3. Designing a spacecraft capable of achieving a soft landing on the Moon is one of the most technically demanding aspects of space exploration. The Chandrayaan-3 mission had to overcome several engineering challenges related to the lander and rover's design, performance, and reliability. One of the most significant challenges was ensuring that the Vikram lander could survive the harsh conditions of the lunar surface, including extreme temperature fluctuations and radiation. The lander had to be equipped with advanced sensors and instruments capable of navigating the moon's terrain with precision. ESRO engineers had to ensure that the lander could perform its descent autonomously, making real-time adjustments based on its environment. The challenge was compounded by the need to account for the moon's weak gravity and lack of atmosphere, which meant that traditional landing techniques used on Earth could not be directly applied. To address this, ISRO's engineers used a combination of software updates, better navigation algorithms, and more robust testing to ensure that the lander would achieve a smooth and successful descent. Another major technical challenge was ensuring the proper functioning of the Pragyan rover. The rover had to be able to operate autonomously on the moon's surface, navigate the terrain, and perform scientific experiments while communicating data back to Earth. This required the development of advanced robotics and autonomous systems that could function in the extreme conditions of space. The rover was designed to be compact, lightweight, and energy efficient, making it capable of surviving the harsh lunar environment for an extended period. Space exploration is inherently fraught with environmental challenges, and the Chandrayaan-3 mission was no exception. The mission had to contend with the extreme conditions of space and the moon's surface. The lunar surface experiences extreme temperature variations, with temperatures dropping as low as 173 degrees Celsius at night and soaring up to 127 degrees Celsius during the day. These temperature fluctuations posed a significant challenge for the lander and rover, as the spacecraft's components had to be protected from both freezing and overheating. To address these challenges, ISRO used advanced thermal insulation materials and designed the spacecraft with mechanisms to regulate its internal temperature. Additionally, the spacecraft was equipped with solar panels to generate power during the lunar day, which would be used to charge the batteries that powered the rover and lander during the lunar night. Engineers also ensured that the spacecraft's components were shielded from harmful radiation, which is a constant hazard in space.
The harsh lunar environment also posed challenges for the rover's ability to move across the surface and collect data. The moon's surface is covered with a layer of regolith, a fine dust that can be abrasive and difficult to navigate. The rover's wheels and instruments had to be designed to withstand the abrasive effects of the lunar dust while maintaining their functionality. The rover was equipped with specialized wheels and tools to handle the challenging terrain, ensuring that it could move freely and perform its scientific tasks. Space missions are expensive and time-consuming endeavors, and Chandrayaan-3 was no different. Despite facing financial constraints, ISRO was able to deliver the mission within budget and on time. One of the key challenges in this regard was ensuring that the mission could be completed without compromising on its scientific objectives. ISRO's ability to design and execute the mission with a cost-effective approach demonstrated its commitment to efficient space exploration. The tight timelines also meant that ISRO had to coordinate a wide range of tasks, including designing, building, testing, and launching the spacecraft. Any delays in one aspect of the mission could have impacted the entire project. ISRO's ability to overcome these time constraints and meet the mission's objectives is a testament to its efficient project management and the dedication of its scientists and engineers. Finally, the Chandrayaan-3 mission faced the challenge of high expectations and global competition. With countries like the United States, Russia, and China having already achieved significant milestones in lunar exploration, there was considerable pressure on ISRO to succeed. The success of the mission not only represented a significant achievement for India, but also demonstrated the country's growing capabilities in space exploration. ISRO's ability to rise to the occasion and deliver a successful mission amidst this competitive environment highlights its expertise and determination. The Chandrayaan-3 mission faced a range of challenges, from technical and engineering difficulties to environmental constraints and time limitations. However, through careful planning, innovative solutions, and a commitment to scientific excellence, ISRO overcame these obstacles and achieved a successful soft landing on the Moon. The mission's success is a testament to the resilience and determination of ISRO's scientists and engineers, as well as their ability to learn from past experiences and apply those lessons to future missions. Chandrayaan-3 has not only advanced our understanding of the Moon, but also set the stage for India's continued growth as a leader in space exploration. The Chandrayaan-3 mission captivated the imagination of students, educators, and scientists alike. How did this impact students, educators, and experts? Chandrayaan-3's impact on education and inspiration for future generations. For young students in India and across the globe, the mission served as a real-life example of how dedication, innovation, and teamwork can lead to extraordinary achievements. The mission's focus on the Moon's South Pole, a largely unexplored region, and its success in achieving a soft landing, demonstrated the power of scientific inquiry and the importance of pushing the boundaries of knowledge. For students, seeing the mission unfold in real time allowed them to witness the practical application of the concepts they study in the classroom, such as physics, engineering, and mathematics. One of the key ways Chandrayaan-3 has impacted education is by making space exploration more accessible and relatable to students. Prior to the mission, space exploration was often viewed as a distant, abstract field, with only a few countries playing a significant role. However, India's success with Chandrayaan-3 has changed this perception, showing students that space exploration is not limited to the superpowers of the world. This democratization of space exploration has empowered young people, particularly in developing countries, to dream big and pursue careers in science and technology. It has demonstrated that with the right resources, collaboration, and determination, nations can contribute meaningfully to the advancement of space science. In India, the impact of Chandrayaan-3 on education has been profound. The mission has sparked a surge of interest in STEM fields among students, with many expressing newfound enthusiasm for subjects such as astronomy, physics, and engineering. The Indian government, educational institutions, and organizations have capitalized on this renewed interest by organizing events, workshops, and seminars aimed at engaging students with the concepts and technologies involved in space exploration. The mission has inspired a sense of national pride as students see their country taking center stage in the global space race. It has encouraged young people to pursue careers in research and development, further strengthening India's future in science and technology. Chandrayaan-3's success has also brought attention to the importance of collaboration and teamwork in education. The mission was the result of years of planning, research, and cooperation among scientists, engineers, and technicians from various disciplines. For students, this serves as a powerful lesson in the value of working together toward a common goal. It highlights the importance of interdisciplinary collaboration, where knowledge from various fields comes together to solve complex problems. This lesson is not only relevant to space exploration, but also to many other fields of study and future careers. Beyond inspiring students, Chandrayaan-3 has also had a profound effect on educators. The mission has provided teachers with a rich, real-world example to bring into the classroom, helping them engage students with complex scientific concepts in a tangible and exciting way. Educators have used the mission to teach about space science, technology, and the importance of research and development. The mission's success also serves as an example of the importance of resilience, as ISRO overcame numerous challenges to achieve its goal. This aspect of the mission provides educators with an opportunity to instill values such as perseverance, problem-solving, and critical thinking in their students. Furthermore, Chandrayaan-3 has encouraged greater investment in STEM education, both within India and globally. The mission has shown that space exploration is not just about discovering new frontiers in space, but also about inspiring new generations of innovators who will contribute to the advancement of science and technology. Governments and private organizations are increasingly recognizing the need to invest in STEM education to cultivate a skilled workforce capable of addressing the challenges of the future. As space exploration continues to evolve, the skills and knowledge gained from missions like Chandrayaan-3 will play a crucial role in shaping the next wave of technological innovations. The impact of Chandrayaan-3 also extends to the broader field of scientific curiosity and innovation. The mission has not only sparked interest in space, but also encouraged students to explore other fields of science and technology. It has demonstrated the interconnectedness of various disciplines and the importance of pursuing knowledge in diverse areas. Students are more likely to pursue careers in engineering, computer science, data analysis, and other cutting-edge fields that are crucial to the future of space exploration and technological advancement. In conclusion, Chandrayaan-3 has had a profound and lasting impact on education and has inspired future generations of scientists, engineers, and innovators. By showcasing India's achievements in space exploration, the mission has made space science more accessible, relatable, and exciting for students around the world. It has instilled a sense of curiosity, pride, and determination in young minds, encouraging them to pursue careers in STEM fields and contribute to the advancement of knowledge and technology. As the world continues to look to the stars, Chandrayaan-3 will undoubtedly remain a beacon of inspiration for generations to come, shaping the future of education and space exploration. International collaboration in space exploration. While the mission was led by ISRO, it benefited from a range of international collaborations that contributed to its success. These partnerships are becoming increasingly important as space exploration evolves into a more collaborative, rather than competitive, endeavor. The complexities and costs associated with space missions require the pooling of expertise, resources, and technologies from multiple nations, and Chandrayaan-3 exemplifies how such collaborations can yield remarkable results. One of the key aspects of international collaboration in Chandrayaan-3 was the involvement of various space agencies and organizations in supporting ISRO's efforts. For instance, NASA, the United States Space Agency, provided assistance in the form of technical support and shared expertise, particularly in the areas of data analysis and mission planning. This partnership reflects the growing trend of cooperation between nations that have historically been competitors in space exploration. Rather than competing, these agencies have come together to leverage their respective strengths and achieve shared goals, such as advancing scientific knowledge about the Moon and preparing for future lunar missions. In addition to NASA, several other international space agencies have played a role in supporting Chandrayaan-3. For example, the European Space Agency, ESA, contributed to the mission's design and testing phases, while the Russian Space Agency, Roscosmos, offered its experience in landing technology. Such partnerships provide invaluable knowledge and resources, allowing ISRO to tap into a wealth of experience and enhance the technical aspects of its missions. This collaborative approach not only strengthens individual space agencies, but also ensures that the broader goal of space exploration benefits from a global pool of knowledge and capabilities. Moreover, the Chandrayaan-3 mission exemplifies how international collaboration can foster scientific advancements that transcend national borders. The data collected from the mission, particularly from the Pragyan rover and Vikram lander, has been shared with the global scientific community. This open exchange of information allows scientists and researchers worldwide to build on each other's findings, accelerating the pace of discovery. For example, the analysis of the Moon's surface composition, the identification of water ice, and the study of the lunar regolith will be of interest to space agencies and researchers across the world. The insights gained from Chandrayaan-3 will inform future missions, both robotic and human, and could shape the trajectory of lunar exploration for years to come. In addition to the scientific benefits, Chandrayaan-3's international collaborations have also paved the way for future partnerships in space exploration. As space exploration becomes more complex and resource-intensive, collaboration will be key to overcoming the challenges of long-duration missions, deep space exploration, and sustainable lunar bases. The success of Chandrayaan-3 demonstrates that countries, regardless of their size or resources, can contribute meaningfully to the advancement of space exploration. ISRO's achievements have not only solidified India's position as a leader in space technology, but also highlighted the importance of fostering international relationships that support shared goals in space science. Looking ahead, Chandrayaan-3 has set the stage for further collaboration in future space missions. India's continued involvement in lunar exploration, including its plans for future missions to the Moon and beyond, will likely see even greater collaboration with other space agencies. As ISRO develops its capabilities, it will continue to build on existing partnerships and form new alliances with countries and organizations that share its vision of expanding humanity's reach in space. These partnerships will be critical in achieving more ambitious goals, such as the establishment of a sustainable human presence on the Moon, Mars exploration, and the exploration of asteroids and other celestial bodies. While the mission showcased India's technological expertise and scientific achievements, it also demonstrated how cooperation between space agencies can lead to groundbreaking advancements in our understanding of the Moon and the wider universe. The success of Chandrayaan-3 underscores the importance of global partnerships in space exploration, where shared knowledge, resources, and expertise contribute to the common goal of scientific discovery and the further exploration of outer space. As space exploration continues to evolve, the collaborative spirit exemplified by Chandrayaan-3 will play a crucial role in shaping the future of humanity's presence in space. So, can humans live there on the Moon? One of the most immediate and dangerous challenges of living on the Moon is its extreme temperature fluctuations. The Moon lacks a substantial atmosphere to regulate temperature, meaning that the temperature on its surface varies drastically between day and night. During the lunar day, which lasts approximately 14 Earth days, temperatures can soar up to 127 degrees Celsius. This intense heat would be unbearable for humans and could cause significant damage to equipment and infrastructure. Without a reliable and sustainable source of heat, humans would struggle to survive the lunar night, let alone maintain the equipment needed for daily activities. The extreme temperature fluctuations make it necessary to develop advanced insulation, heating, and cooling technologies to protect both human life and machinery on the Moon. The Moon's lack of a protective atmosphere is another terrifying truth that makes living there particularly hazardous. Unlike Earth, which is shielded by a thick atmosphere that protects life from harmful radiation from the sun and cosmic rays, the Moon offers no such protection. The Moon's surface is directly exposed to these deadly radiation levels, which can have severe health effects on humans over prolonged exposure. Solar radiation, cosmic rays, and the lack of a magnetic field increase the risk of radiation sickness, cancer, and genetic damage for anyone living on the Moon. Without an atmosphere to block out this radiation, lunar habitats would need to be shielded with thick materials, such as lunar regolith, moon dust, to reduce the harmful effects of radiation. This would add to the complexity and cost of constructing any kind of permanent human settlement on the Moon. Even brief stays on the Moon could result in significant radiation exposure, and long-term habitation would require robust protection to ensure the health and safety of residents. The Moon's surface is covered in a fine, abrasive dust called regolith, which is created by millions of years of meteoroid impacts. This lunar dust is highly problematic for both human health and technology. Regolith is not only sharp and irritating to the skin and eyes, but also presents a serious risk to the human respiratory system if inhaled. The dust particles are incredibly small and can easily become airborne, infiltrating habitats, spacesuits, and equipment. One of the most significant challenges to living on the Moon is the lack of readily available water. Water is essential for human survival, not only for drinking, but also for food production, sanitation, and oxygen generation. While scientists have discovered traces of water ice in permanently shadowed craters at the lunar poles, extracting and utilizing this water is a daunting task. The amount of water available in these deposits is limited, and harvesting it would require advanced mining technologies and significant energy resources. Without a local source of water, any moon colony would have to rely on Earth-based supplies or develop technology to extract water from the moon itself. However, transporting water from Earth would be costly and impractical for long-term habitation. As a result, any sustainable human presence on the moon would require innovations in water extraction, recycling, and conservation to ensure that humans can survive without constant resupply missions from Earth. The moon's gravity is only about 1/6 that of Earth's, which may seem like an advantage in terms of ease of movement, but it poses significant challenges for human health. Prolonged exposure to low gravity can lead to muscle atrophy and bone density loss. On Earth, our bones and muscles are constantly engaged in counteracting gravity, but in the moon's reduced gravity, this process is weakened. Over time, astronauts may experience a decrease in muscle strength and bone mass, making them more susceptible to fractures and other health problems. While short stays on the moon, such as those experienced by the Apollo astronauts, did not result in long-term health issues, a permanent settlement would require countermeasures to mitigate the effects of low gravity. This could include artificial gravity systems or regular physical exercise to maintain muscle and bone health, which would add to the complexity and cost of living on the moon. Living on the moon would not only be physically demanding, but also psychologically challenging. Why? The isolation and confinement of living in a lunar habitat, far from Earth and separated from family and friends, could take a significant toll on mental health. The moon's barren, desolate landscape and lack of natural beauty could lead to feelings of loneliness, depression, and anxiety. The psychological challenges of space travel and habitation are well documented, with astronauts often experiencing stress and fatigue during extended missions. Indians, through the ISRO, have not directly explored the possibility of making the moon livable for humans yet. The potential for lunar habitation remains a topic of interest globally, and countries like India are working towards understanding the moon better before considering long-term human settlements. These missions, including the Chandrayaan series, are important stepping stones toward assessing the feasibility of establishing a sustainable presence on the moon. However, making the moon livable for humans would require overcoming significant technological and environmental challenges, which are still being researched. We are yet to see what Indian exploration will discover in the future. Thanks for watching the video, and we'll see you in the next one.